Hi folks, this is a video to introduce the components associated with the inverse square law lab, where we're trying to figure out the behavior of light intensity as a function of distance. As you get further away from a light source, the light gets weaker in intensity, and we're just going to look at the mathematical behavior of this and show whether or not it behaves as a 1 over distance squared behavior. So what we need to do is go through each of the various components here that you need to put together. This is the optical bench here. You're going to need to get one of these from the room. And then on top of the optical bench, you're going to set these three components here. The first one here is the light source. This is the LED, white LED light source. You can see it back there. Now, because the LED circuit board is recessed about 18 millimeters below the surface of the aperture here, what we have to do is move the light source here, the notch here at a point of 18 millimeters or 1.8 centimeters away. Move it to right about there. About 1.8 centimeters from the edge here. That way the LED, which is back here, lines up with the 0 centimeter mark. This is important to do that before anything else. Now you also need to grab an adapter for the light source itself. I already plugged mine in. And we need to set this to the circular opening here. So there's other settings on here, but the circular one is one we want. Now, when this is on, there's a lot of light scattered off of the surface of the printed board that you see inside there. The yellow thing is the LED, but there's a lot of light scattering inside there. We want to reduce the amount of scattering by putting an aperture in the way here. So this aperture with the smallest hole opening is the one we want to use so that light comes out this way. Now, as the light comes out this way, it's going to hit a holder with a photometer. This is a photosensor, a light sensor. What this does is basically collects the light here, sends the information down through this box, eventually to the LabQuest box, which is the interface that you need. You'll need to grab one of these along with its associated adapter as well. Turn it on by using the top left button up here. All right, there's a button. And let that sort of like cycle up to this point here. Now, with the photosensor, this thing here, what you want to do is make sure that the little, try to focus this here, that the two yellow little dots on either side, you can see them there and there on either side of the photosensor. You want this to be horizontal, all right, so that it gives the maximum ability to read the light coming out of the light source, all right, so make sure that's the case there. There is a little turn screw on this side to tighten it up so that you can actually get this to stay put, all right, as you move this thing back. So this is connected over here by means of this cable here. When you plug this in to channel 1, which is right here, oh boy. There we go, nice click, and you should lean and give you the number here. So this reading here is in lux, arbitrary units for light intensity. Now, the setting for the amount of light intensity you want in terms of the range is right here. We want it set at 0 to 6,000 lux, not the other ones, all right? So 0 to 6,000 lux for this particular lab. Now, I'm gonna turn the light on over here. You can see the illumination is making its way over to the sensor. It may not be perfectly centered, but that's okay. We don't need it to be. And then we're getting a reading over here in terms of the light output. Now, once this is all set up, you're going to turn the lights off, turn this light off, get a background reading, all right, because the lights are off, you're going to get some stray light still hitting the photometer here, the photosensor, and so you'll probably read something that's close to 5 lux here. In the Excel spreadsheet, I wrote down 5 lux in there as the background, but your value may vary depending on if you're closer to a door or to another external light source. So change it if you need to, all right, but the standard is about 5 lux. Now, once you have that put into the spreadsheet, you're going to conduct your experiment by collecting the information. So assuming the lights are off in this room here, what you're going to do is you turn the light on. You're going to move this to the first point here, which is going to be 10 centimeters. All right, so 10 centimeter mark. Get your reading. The reading's going to be over here. All right, you don't use this because the lights are on in this room, so this is not good. But you do this while the lights are off in the room. You get your reading of 10 centimeters, you get your reading of 15 centimeters, 20 centimeters, and so on, all the way down. So you just basically slide this back to the next position and get your reading, and then move to the next one, get your reading, and so on, right? You continue on the way downwards in 5 centimeter increments until you get to 120 centimeters, which is right here. This data collection of the distance and the intensity is going to be put into an Excel spreadsheet. And once you put it in there, the background will be subtracted off, and then it'll automatically plot it for you in the graph provided. What you'll do at that point is follow along in the lab outline itself to get the exponent. In other words, you're going to be doing a curve fit on there, which is a power fit. And then from that, you'll be able to read what the exponent is in terms of the trend line that is given for the data. All right. And so once you have that, and assuming that is pretty close to -2, then you do a percent error calculation to see how close it is. If it's within 10%, then you're good. And that's how this lab works, okay? And then provide some concluding remarks to basically, finish the lab where the sources of error could be, if there are any sources of error. And that's basically it. All right, carry on.